We get to do more proofs on this one, and we're going to be talking about midpoints or angle bisectors, partial segments, that sort of thing. One thing you need to understand is a definition of a segment bisector. That just means that you're taking a segment and dividing it exactly in half. So that means, so example, this line M is a segment bisector of segment AB. That just means that the distance from A to the line is equal to the distance from B to the same line. And then an angle bisector just talks about how it's going to divide an angle exactly in half. So bisector just means in half. Midpoint means it's right in the middle of a segment. And midpoint between 2 points is the average of those 2 points. So you can add them and divide by 2. When you want to find the midpoint of 2 points, you can add each coordinate and divide them both by 2 to get the midpoint of those coordinates. And then vertical angles, just like these right here, EFD and HFG, those are called vertical angles, and those will be congruent. So it looks like we're going to probably use some of those too. So let's go on to the first example. So let's see, what are we given? GD and bisects HE. Okay, so let's write down what we're given. GD bisects HE. Okay, so we know that these two are congruent. And then HE bisects GD. Okay, we know these two are congruent. Then we're going to show the vertical angle theorem. So can you see that these two triangles are going to be congruent by side, angle, side? Wait a minute, I didn't have to put 2 arcs. I could have just done 1. So we're going to show this by side, angle, side. Let me write that down so we don't forget. And we're going to have to use vertical angles. Okay. Oh, and we're going to have to show the 2 sides are congruent. So because these bisect, we're going to have to use definition of bisector and show that GF is congruent to DF. So we'll show that one first. GF, right arrow, congruent to, what did I say? DF. That is definition of bisection. Do they have that? A segment bisector. Woohoo. Then we're going to do the same one. So HF and EF. HF is congruent to EF. So just so you know, that's also definition of segment bisector. But I am actually looking at the order that I'm writing these segments. So GF, I'm looking at the triangles that I'm proving, and G is the last letter and F is the middle letter. So it has to be congruent to DF, which is the last letter, middle letter. Same with the HF and EF, they're the first 2 letters in order. Okay, now we're going to show the 2 angles, and so it's HFG. So I'm going to use these 3 letters in this order, but with angles. So angle HFG is congruent to angle EFD. And that's going to be the vertical angle. Where is it? Did I pass it? Vertical angles property. There it is. Now we have, what do we say? Side angle side. So we're going to say they're both by side angle side. Validate. And that's going to be our proof. Okay, so on this one, they're going to say EF is congruent to GF. EF, GF, that's just given. DF bisects angle EFG. So we're going to know that these are by definition of angle bisector. And then we can tell this is congruent to itself by reflexive. So that's side, angle, side again. And we're going to use the reflexive property on that one by itself. Okay, so first we're going to send this to proof. We're going to send that to proof. Because it's bisecting, we're going to show that these two angles, DFE, so angle DFE is congruent to angle. Now, what order did I do? Let's see, DFE, so DFG. And that is definition of angle bisector. So we use the angle bisector. There we go. Okay, and then we're going to show DF is congruent to DF, the segment. And that is by the reflexive property. And then we can show, so wait, we had this side. We showed the angles, and then we showed this side, so side angle side. So we're all done. We can show the reason to be side angle side, and we're all done. And we'll go on to the next one. Okay, so let's see. TR is congruent to QR. TR, QR, that's given. R is the midpoint of SP. Okay, so definition of midpoint, these will be congruent. And then we're going to do the vertical angles theorem. And then we have what? Side angle side will be our final reason. So we're going to send this to proof. We're going to do this. We're going to talk about the definition of midpoint. So since R is the midpoint, we can say SR is congruent to PR, the segment. SR, that segment is congruent to PR. And that is actually definition of midpoint. So we know if it says midpoint, then those two are congruent. Now we're going to do the angles TRS, and I'm going to use the same order, QRP. So angle TRS is congruent to angle QRP. And that's going to be the vertical angle property. Vertical angle. Uh-oh, I went past it, didn't I? You guys could probably see it, and I didn't. Okay, I can't see it. Slow down here. Aha, there it is. Okay, then, so we had the side, the angle, side angle, side. Okay, so we're going to go ahead and use the side angle side. Hey, all of them were side angle side. That's interesting. Okay, that's the end of the lesson.